Merry Christmas and Happy New 2025. In this video, I will be explaining Termi's codebase and Termi itself. This video will feature a mix of diagram drawings, animated diagrams using Manim library, code zooms, and of course, talking. Sit back and enjoy the video.
Hello and welcome to the new video. We are talking about Termi and all of the code which is powering Termi. I actually filmed this video to talk about version 3.2.0, which is the latest version released for Termi. But I have done yet another refactoring of Termi. Hopefully this will be last big refactoring of Termi to a few days ago. It started here, so yeah, 5 days ago. So I decided to make a new video, edit it, and post it on YouTube. Let's get started.
There are just a few things I want you to listen more carefully. These are simple versus advanced console mode, how is GUI initializing Termi and relationships between console and GUI, and how is simple console mode interacting with commands.
So Termi is a powerful terminal emulator with an optional custom shell written in C++ with OpenGL and their GUI. The goal of the project is to create an independent terminal environment with its own commands, rendering system, but it is still able to access usual terminal environment like executing bash or zesh, something like that. It's written in C++. You can run on Windows, macOS. We didn't test that, but it should be able to run macOS, GNU/Linux, and BSD. We have tested Linux and BSD. And it said here our own rendering shell system. We have two distinct running modes. Simple console mode,
in which you can only execute one process, and while that process is running, you cannot interact with it. It supports arguments, but third-party applications have to be modified so they can access printing functions from Termi GUI. And when process gets executed, you can normally execute another process like in any other shell.
Advanced console mode will make a real terminal emulator like Alacrity. It's terminal emulator, and you can it's running a shell, and in shell you can execute things like help, let's say ls, but Termi will come with its own shell. In first version we have, I don't know what we have, I forgot, but not really advanced. Then in second version we have simple console mode, which can load commands from separate dynamic library.dll or .soe file. Then we have version 3, which feature one code base. Before there was special for Windows code, and for Linux code it's one code base. Tabs were implemented. New JSON entries, and in version 3.1.0 there was networking and BSD macros. These macros are very important. Networking is also important. 3.1.1 we just replaced Go license to MIT license, and version 3.2 huge refactoring, better settings handling, better translation, basic refactoring, and development of version 4 new GUI model. It's actually to using console mode now. So yeah, new console mode which supports interaction with executing process. Basically, you can run a shell, and networking for Windows, and also refactoring of networking in general. This is latest version. I have done a refactoring. I basically prepared terrain for making advanced console mode. No refactoring needed, I hope. So yeah, I'm ready to work on shell and advanced console mode. Now let's go into the code editor. I use Visual Studio Code with Groovebox Art theme, and let's go through the code. This is just Windows release for launcher. I'm not going to explain this. Terminal launcher, just launcher from Tom Whelan tutorial. Installer, setup installer, Termi client, this will get moved into Termi with new refactoring. Okay, so let's go from the beginning, Termi main, which is basically code for loading dynamic library, calls Termi GUI. As you can see, it loads Termi GUI. Now we have a bunch of includes here. Okay, so let me explain what technologies we are using. So we are using AmGUI, and AmGUI is a intermediate GUI library, GUI library, which works on multiple APIs, libraries, etc. We use OpenGL, but OpenGL is an API, and we need to somehow interact with that API, and we are using GLF. It's a library for OpenGL. We are also using Glad to load our OpenGL. In README, there is a good instruction manual. You can say that how to install uh, OpenGL, how to install GLF and Glad. So it's Windows, so you first generate files and then you continue with installation. And it's for all other platforms, you generate files and continue with installation. There is also this video for Linux, other platforms, and this is for Windows from Victor Gordon. So yeah, it's explained very well. And if you're not lazy and read everything and watch everything in its entirety, it's going to be very clear what to do. This is Control C code. Okay, this is function for setting font. You can set font. It gets from settings class, font name, etc. And this is the main function for GUI. We print this Termi. This is legacy thing icon. And here we initialize GLF window again from settings class. And this is main loop, which initializes GLF and calls Simon GUI code. We are passing this window which we are getting a window size because we can resize window. Right, GLF and GUI has to resize alongside GLF. That's why we read GLF window size before calling IMGUI. I think this is very clear, nothing special here. Let's go here. This main code. Here we create a window. We will come to this render variable and all of this, and that's it. Then we have this very important function, and we will talk a lot here. So this is draw tab function from my GUI demo.cpp. It draws tabs, and here we have a code. We have this vRenderer and vRenderer ID global variables. vRenderer is a vector which holds unique pointer, basically the memory save pointer of console base class. Now I have to explain what console base is. Console base is a class, is a basic class which all other console modes inherit, like polymorphism, right? But let's see what they inherit, what they do. So we have a class vars, which are runtime variables. Runtime variables, and we have a class GUI, which implements a menu. Actually, I think it should be smart to show you Termi. This is what GUI does. This top drop down menu. That's GUI. That's what GUI cares about, right? And we have console base, which is base class for our console mode. Console base has functions which all other console modes should have, and that's draw function and add log. Now, advanced console mode will not need add log, but I didn't know how to incorporate because it's an external C block. I'll come to that later, why it's an external C block. So yeah, I had the problems here. I will explain it later. So it's here, even though it's not gonna be used advanced console mode. So yeah, that's console base class, and this XRC block. Now let me explain why log is here. Log is here because when dynamic library, it's gonna call this function from Termi GUI to print on the screen. So we are going to have command com is going to use add log to print to Termi Termi GUI, right? So and uh, function has to be in external block and cannot be in class because due to C, because it has to also be accessible from C, and how C++ is compiling, and ABI, all these calling conventions. It has to be just a function, cannot be a class due to compatibility reasons. And tmain for termi to load GUI. Now, it draw menu, draws a GUI function. Right, it goes this GUI function, and I'm just implementing a choose language dialog function. This is 10 things. And here we have a draw function for console base, and of course it's nothing because no universal code here. And now we renderer, as I said, is vector holding all those instances of console base, and console base also holds instance of GUI. So each tab has its own instance of console base and therefore of GUI and variables. And since it's a vector, it has multiple elements. We use this variable to keep track of current render element in use, and we only render one which is in use. So we render n is current open tab, and we draw that. Now I want to say that 2 comments before I was using v render id everywhere, but that was unnecessary because I was accessing my own variables. So GUI was accessing its own variables in its own instance, so there's no need to call global variables 100 times, only when drawing this. Polymorphism is kind of cool. So yeah, uh, that's how things work in Termi. We have no class associate function draw tab, which draws console base class, which inherits GUI and variables. It draws GUI and variables, and but actually we don't draw console base. We don't call it because other classes override console base. As I said, other classes, console modes, override console base. So we're basically drawing console mode, and it is simple console mode, which is borrowed from mguidemo.cpp. So let's recap. We have also a diagram here. So draw tab draws one element in vrender vector, and that variable is type of console base, and console base is overridden. These are virtual functions. They are overridden by another class, and they get executed, and they also inherit GUI and variables. So each tab is its own instance of console, GUI, and variables. So this is a code from my GUI demo.cpp. We have some variables here, and we have a map of default commands which come which term this simple console mode. This code is from one of the GUI issues. Split string is it's probably from no, it's from internet. So yeah, we basically push back basic commands, and we iterate through a map and push elements to vector from a map, and we sort them. That's it. Now this is interesting function, low dynamic library. We are using template. This is included in 3.2.0 version. We are using template B here because we can load Termi commands, which is using a vector, std vector for commands, for arguments, and we can load third-party applications slash programs slash commands, which are using constant char pointer. So for third-party applications, we pass arguments in form of one constant char pointer string separated by space. So let me visualize. So this is v1 word 1, v2 word 3. This is space, and this is one string constant char point. And now I have realized that we can use a template for both functions, because before we had one function for std vector, other for constant char pointer, but arguments templates work for this, so let's use templates. This is Windows code, and this is Unix code, so pointer and type name, variable type, so point and name, pointer function, and type is t, template. Here we just do reinterpret the cast to ignore errors, and here we send an argument of t, of type t is template. This draws the camera emulator thing where you input and this executes a command. We have a command line. We that is history, and if history is too big, we delete the rest of it. We actually remove just first element then to fit a new one. Here we separate into arguments, so command line is this, and we are then searching for command in table, and if table is command is found in table, so we haven't reached end of the map, we get result, and we load dynamic library commands path. Result is function name, function name, and we pass the argument in form of std vector. And for other functions, and load tp, which loads third-party applications. So yeah, as I said, argument is we put all arguments into one string, and you do parsing inside your own application. This is it for simple console mode. Advanced console mode is just class initializing, nothing special. Network has to do refactoring. We are currently using code from some chatroom project. This I'm GUI, this is utils settings. We're using JSON-C library. Nothing special in here when translation. So you just have to care of order or order of languages. So you have how it's sorted here, it has to be sorted here. So if English is first, Croatian second, English word has to be first, then it has to be Croatian. Actually, in second parameter, you exclude English language. You this translation vector or translation vector. This is original English string. Not maybe the most efficient way, but it works. This is Termi GUI. Let's go to Termi commands, and here we have again template thing and some Windows functions template thing, and here it is below constant char pointer thing, because it has to be available from external C block. If your function is in external C block and tries to call this function via templates, it's not gonna work. It's not going to work. So you have to explicitly instantiate a template so it's available in external C block, because C does not recognize it's not just CS, it doesn't recognize templates, but for compatibility reasons with other programs and calling conventions and everything. Add log function and status. And this is commands implementation of our basic commands. I'm not gonna go through that. Nothing special in that. Yeah, because this is why we needed instantiation, because here in the yes function we are kind of calling Rust to show that you can use any language for making commands for simple console mode in Termi. And also it's important for these functions to be in external C block because they have to be accessible to Termi GUI. Termi GUI is gonna call them, so when you are exporting functions for dynamic library, they have to be in external C block. Use this export macro because Windows is like weird and which see decal spec deal export while you see Linux is just this. And this is Rust. This Rust function, we have this function for separating string, as I said. String arguments are sent as one string, and we have to do parsing inside our own application. And here we do parsing. For one constant C char, we return a vector C string, and this is addlog. Just calls it calls termi GUI and addlog function. Here we have a GUI path in form of macros, constant string in Rust. Here we are loading libraries to load dynamic to load functions from dynamic libraries and to be able to use constant C char type. Yeah, for that interoperability, we need to use a library. It's not a library, it's a crate in Rust. If you want to pour something to simple console mode in Termi, you need add log function to access Termi's GUI console. To use Rust, you have to use some crates for interoperability. For C and C++, interoperability is already there. You also need a function to parse arguments. So you get one string, and you have to separate a string in a vector or anything else you want. And you have to make it the external C function to make it visible so it's accessible. And for the end, we have Termi-Shell, which I just started making, custom Termi-Shell for advanced GUI mode. So at the end, I think that you have a pretty clear understanding of how Termi GUI works. That we have console-based class, GUI class, variable class, and console mode classes, and that uh, simple console mode works from dynamic libraries. Termi calls dynamic library function, and dynamic library calls Termi GUI back only for printing purposes. There's no communication while the process is running. You just GUI just calls a function, and function just prints things. Advanced console mode will of course be able to execute executables. You'll execute Termi-Shell or any other shell, and via shell you can access other things. That's how it works. You have shell, and you do things via shell. Uh, it's interesting project. Term is interesting project because it uses GUI. It might not be the memory least intensive application, least resource intensive application out there, but it's interesting proof of concept to create an independent terminal environment. There may be some use cases for it, maybe not, but it's fun to play with OpenGL. Desktop applications, even though that's not the recommended way, and to play with terminal emulators and shells and executables and dynamic libraries because it's kind of low level thing. Those all of those calling conventions, executables, formats, everything, all of that is a low level thing, and I love low level things. We are Ringo and Go, no, non-profit software development group love low level things and desktop applications. So yeah, we also have a Baker, which is also a low level thing, and form of desktop applications, at least parsers. So yeah, if you like Termi, give it a star. Join Ring or Go Discord server. Support our other projects on Ring or Go. Start them. If you like this video, like and subscribe. And I hope I have made some animations. And subscribe and see you in the next video.